Hello there. Today's lesson is just going to extend on what we did yesterday in class dealing with parallel lines cut by a transversal. And so yesterday we looked at two parallel lines cut by a transversal and we proved some relationships true. Today we're going to go backwards. We're going to assume that we have some relationships that are true and we're going to try and prove that two lines are parallel to one another. So yesterday we said this again: if two parallel lines are cut by a transversal, then corresponding angles have equal measure. And we also proved that alternate interior, alternate exterior have equal measure as well. Today we're going to look at this second bullet point here. We're going to look at to see if you have corresponding angles that are equal in measure, then we're going to try and prove that lines are parallel. So you got to flip your thinking. Now what we're going to do is dealing with a diagram like this today, where it appears that the lines might be parallel, may not be parallel, and our goal is to try and show that the lines are parallel by proving that corresponding angles are equal in measure. So we're going to do two proofs today, and I'm going to walk you through those two proofs, and they're going to mirror what you can do in your classwork. So you can copy down the work that I do here into your classwork, and then you're going to do two additional proofs on top of that. So in this first problem, you can see our given information is not the fact that we have parallel lines, but rather we're told that two angles are equal. That's angle 1 and angle 7, which are alternate exterior angles. And based on given that information, I'm going to try and prove that these lines are parallel. Now, in order to show that the lines are parallel, I have to show that corresponding angles are equal in measure. So my goal right now is to prove that a set of corresponding angles are equal in measure. But just within any proof, the first thing that I need to do is write down my given information. So just like we did yesterday, I'm going to try and highlight some angles that are equal to each other that I already know from the picture. I've marked down my given information, and the next thing I'm going to do is I'm going to identify a set of equal angles to eventually try and substitute back in to show that I have some corresponding angles that are equal to one another. In order to do this, I'm going to try and show that angle 3 and angle 7 are equal to each other. If I can prove that 3 and 7 are equal, that would then justify that I have corresponding angles equal in measure, and therefore these lines would be parallel to one another. So in my next step, I want to show somehow, I already know 1 and 7 are equal, that's given. I want to try and show that 1 and 3 are equal to each other, and then eventually I can substitute in to show that 3 and 7 are equal. So my next step, I'm going to say 1 and 3 are equal because of the vertical angles theorem. Now at this step, I have angle 1 equal to angle 7, angle 1 equal to angle 3, and so then using the transitive property or substitution, I can show that angle 3 is equal to angle 7 merely by substituting in right here angle 3 back in for angle 1. So that's going to be my next step. So as you can see here, what I've done is I've substituted angle 3 in for angle 1, therefore 3 is equal to 7, so I'm just pretty much replacing this angle 1 with 3 up here in the last step. Now angle 3 and angle 7, as noted several times, those are corresponding angles. I just showed that those are equal in measure to each other, and therefore I can say that this line here, L, is parallel to M because that's because of the parallel lines postulate. Remember, that's a biconditional statement. So showing corresponding angles are equal then justifies that these two lines are parallel. So again, my final step is to say that the parallel lines postulate shows that L is parallel to M, and my reasoning for that is because I have corresponding angles are equal. So this is one proof that I did for you. There's another one that's going to be very similar that I'm going to ask you to do when you're done watching the video. I'm going to do one more proof for you that's going to be dealing with same side interior angles at the same point. Alright, so in the second proof, what we want to try and do is we want to try and show again that corresponding angles are equal to each other. And now I'm going to use the same corresponding angles as last time. I'm going to try and show that 3 and 7 are equal, therefore showing that these lines are parallel by the parallel lines postulate. But in this case, we're given a little bit different information. Here we're given 2 and 7 equal 180 degrees. Those are same side exterior angles. I'm going to use that given information to try and prove these lines are parallel. As always, we're going to write down our given information first. From that point, I'm going to use the fact that I know that 2 and 3 also add up to 180 degrees. And I want to show that 2 and 3 add up to 180 because they're a linear pair. Doing that will allow me to have a second set of angles that add up to 180 degrees, and eventually I'll be able to substitute them in to help me try and find that 3 and 7 are equal. All right, now that I said that those are the same because of, or supplementary rather, because of the linear pairs postulate, I now have both these equations equal to 180, so therefore I'm going to set them equal to each other since they are both equal to 180 degrees. So again, I've highlighted that I've shown that I took the measure of angle 2 and the measure of angle 3 and substituted that in for 180 degrees in this third step. Now I have this equation, and if you note, I have both the measure of angle 2 on both sides of the equal sign, so all I merely need to do now is subtract the measure of angle 2 from both sides, and I'm just going to end up with the measure of angle 7 equaling the measure of angle 3, which happen to be the corresponding angles that I want to prove are equal. Now that I have angle 7 equal to angle 3, I know those are corresponding angles, and because of the parallel lines postulate, I now know that line L is going to be parallel to line M. And so that's going to be my fifth step, what I'm trying to prove, that that line L is parallel to line M, and my reasoning is because of the parallel lines postulate. So now I have it. I proved line L is parallel to line M. I've done two proofs for you, so when you download your classwork, there's going to be a couple of warm-up problems that you should do with the people at your table, kind of what we've done over the last couple of days. Then you'll see these two proofs. You can fill them in if you desire, but there's two additional proofs that are very similar to this. Just working with this deductive reasoning and the parallel lines postulate going the other direction. You can look online. You can look at the filled-in notes online as well if that's his benefit to you. But I hope that you enjoy the rest of the time in class, and I'll be around on Friday morning if you need any extra questions.